Hi, good day everyone. So today we will be doing May-June 2025, number 9. Alright, so the question says, a ship sails from point A to point B, which is 15 kilometers from A on a bearing of 42. The ship sails from point C, then sails to point C, which is 19 kilometers from B on a bearing of 130. The following diagram shows the sketch of this journey. So first off, we don't have B and C, but looking at the lengths that was given, from A to B is 15 and then from B to C is 19. I would say B could be here and C could be here. Again, it doesn't matter which one it is because it is a sketch, it's not diagrammatically correct. Right, so it's up to you. From A to B, they told you it's 15 kilometers. Right, and then they said starting at A because they said from A on a bearing of 42 to B, right? So starting from A and your north line to line B should be 42. Right, and bearings is always represented as 3 digits. So don't just write 42, put 042. Then the next thing is they said the ship then sails to point C, so from B to C, which is 19 kilometers, right? And from B, we're going to see, they told you it is 130 degrees, right? Now they told you the following diagram shows a sketch of the journey. Part 1 on the diagram, insert the bearings of 42 degrees and 130, which we did. Calculate the distance between tongue A and tongue C. So they want to know from here to here. Now to do that, you either use a sine rule or cosine rule, because again, this is not a 90 degrees triangle. So to find any length, you have to use your sine rule or cosine rule, and it depends on the properties given. That is what you would choose. Now, in this question here, and for both sine rule and cosine rule, you do need an angle in your triangle. So you need to determine which one can you figure out best. Right? Now, one of the rules that you should understand is that your north lines are parallel to each other, and then we have this line. So let's say this is A and this is B. We have two parallel lines intersected by a transverse line. Your internal angles are supplementary, meaning 42 plus this angle here should give you 180 degrees. So to calculate this angle here, I would say it's 180 minus 42. When we do that, right, you know that this angle here is 138. Right, you can calculate this angle. Let's put it in a different color so you can see it. To calculate this angle here, we can see that this is an entire rotation, an entire circle, which is 360. So if I add my green angle plus the red plus the black, I'm supposed to get 360. So my green angle here can be calculated by 360 subtract the summation of this 138 plus 130, right? So let's do that. 360 subtract 138 plus 130, right? So when we did this, the answer will be 92. Right, this would be 92. So looking at this, we have two sides given and angle that is produced by these two sides when intersected. So therefore, the rule that must be used is cosine rule. Alright? So looking at, let's just label the sides. Looking at this would be common C, this is common A, and this is common B. Right, so let's make a formula using the cosine rule, using the sides that are given. Right, so we know cosine rule will tell us, because it's side B we're trying to find out, it will be B squared is equals to A squared, common A, so that's the sides we're talking about, plus C squared minus 2AC cos angle B. Right? So now let's fill in the values. We know B squared, we don't know what B is, it's equals to A squared, so A is 19, so 19 squared plus 15 squared minus 2 by 19 by 15 cos 92. Right, okay, so I just move it to the working space. Right, let's see, it's supposed to be here, it's supposed to go back. Alright, so now we are going to solve this. 19 squared is 361 plus 15 squared is 225 minus 2 by 19 by 15 is 570 cos 92. Alright, so B squared is equal to that. So we want side B, which would be the square root of open bracket 361 plus 225 minus 570 cos 92. Exactly what I have here. You can put in your calculator. Alright, let's just bring up the calculator so you can see how to do it. I'm using the sharp calculator. I'll show you guys how to use the Casio just in a minute. So it would be the square root of open bracket 361 plus 225 minus 570 cos 92. The only thing I would have to tell you is make sure you put your brackets. Also make sure it is in degrees. Your calculator is in degrees. You press equal, so your side should be 24.61. Now we'll put it to one decimal place. So side B is equal to 24.6, and we know that this is in kilometers, so this would be kilometers to one decimal place. Right, your Casio is not that much different. However, your Casio is programmed to find the square root of everything in under the square root sign. So if I put square root here, right, I don't need to put open bracket. Right, so 360 or close bracket 361 plus 225 subtract 570 cos 92. Close bracket there. Your calculator is this D here is for degrees. You press equal, and I am going to get the same answer. So your Casio is programmed to say I need to find the square root of everything in your bracket. However, the sharp calculator is not. Alright, so you do have to put those brackets if whatever calculator that you're using, you just need to follow those rules. Alright, let's look at the second. Determine the bearing of tongue A from tongue C. So let me just put in the information that we know. So they said 200, this is 24.6 kilometers. Alright, they said to find the bearing of tongue A from tongue C. So they want to know this angle here from tongue C to A. Right? Now to do this, first off, we need to find two angles. So we know this is 130, so let's just gonna do this in blue. So this angle here is, again, we have two north lines and a transverse line, which is line BC, intersecting those two parallel lines. That means that the internal angles are supplementary. So 130 plus this blue angle here should give you 180. So this would be 180 minus 130, which is equal to 50 degrees. Right, so this is 50. We don't know what this angle is. We know, so we have to find out this angle here first and then subtract. So the black angle, the bearing of tongue C to tongue A, or point C to point A, would be 360 subtract 50 plus, we need to find this angle here. Let's call this angle C, and that would give you what is the bearing. So to find this here, we can use sine rule, right? Can we? Yes, we can use sine rule because we have a side and its angle, as well as we have a side and the angle here. So let me just, okay, so I just put a picture on the next page. So let's find out or determine what we can use. So we can use, we know it is, or sine rule states is side A over angle E. Excuse me. Alright, so we know that it is A over sine, I wouldn't be using E, I would be using C. So we know it is B over sine angle B is equals to, because we're trying to find out this angle which we call C, it would be side C over sine angle C. We know that B, which is your side, is 24.6. Angle B is 92. C, side C, is the side opposite this angle, so this is 15. Just put kilometers, and we need to find angle C, which means call it C. Right, so let's put it, that's 24.6 over sine 92 is going to be 15 over sine C. So let's calculate this. This would be 24.6 divided by sine 92. Alright. You know what? Let's do this total thing. So you carry across, divide by C, will turn to multiply. So it'll be sine C multiplied by 24.6 over sine 92 is equals to 15. Then you would carry this across because you want C with the subject. Right, so sine C is equals to 15 divided by 24.6 over sine 92. Then C would be, carry this across, that's sine inverse of 15 divided by 24.6 over sine 92. Close bracket. Right, so this is how you would do everything you would do to just find that angle C. Right, so let's do it on the calculator here. Again, I'll do it on the Sharp first, and then I'll do it on the Casio. Right, so we have second function sine, which is sine inverse, open bracket, 15 divided by 24.6 24.6 over sine 92, close bracket, press equal, and I should get 37.5. Alright, so C should be 37.5 degrees. No, yeah, degrees. Alright, let's use the Casio now. Again, when you're dealing with angles, unless stated otherwise, use degrees. So we have sine inverse. Where am I? Right, sine inverse is shift sine to get sine inverse. You already put the bracket, so you don't need to. 15 divided by 24.6. I should put this over. Hold on. Let's put it as a fraction, right? 24.6. Press this here, go down. Sine 92, right? And then close bracket. Press equal. Oh. Maybe it's that fraction part. Yeah, I forgot a close bracket by the 92 degrees, right? So the answer would be, again, 37.5, right? And that is how you would do this. Now, if doing this entire thing is also a bit confusing, you can do it step by step, which is we can find 24.6 divided by sine 92. That's this here. Press equal, you know it's 24.61. So 15 divided by sine C, let's write that down. 15 over sine C is equals to 24. Let's get it back. 0.61, I believe. Yeah, 24.61. Then you carry this across here, you'll have sine C multiplied by 24.61, because if I carry across, divide by, will turn to multiply by. It's equals to 15. Then I want sine C by itself, so I'm going to carry this across. So sine C is equals to 15 divided by 24.61. C would be, if I carry across sine, it would be sine inverse of 15 divided by 24.61, close brackets. Alright, so let's do that. We should get an answer close to. The reason I'm saying close to is because I approximated here, right? 24.61. I didn't use the exact answer. So second function, sine to get sine inverse, open bracket, 15 over 24.61, close bracket, press equal. I will, you see, I'm getting it. Close enough answer, 37.5539. So you can do it like that, or you can do it like this. It's up to you, whatever you're comfortable with. Right, but that doesn't answer the question. Let's just zoom up underneath to see the diagram. Right, we know that this now here is 37.5, right? 37.5. So this angle here, I already told you, it's 360 minus 50 plus that. So 50 plus 37.5 is 87.5. So that's 360 minus 87.5. So 360, subtract that, is 272.5 degrees, and that is how you would do this question here. So the answer is 272.5 272.5 degrees is the bearing of tongue A from tongue C. So meaning you're starting from tongue C, going to A. Just a rule of thumb for bearings, it's always in a clockwise direction, not the shortest. So that is why I had to start from here, go straight around. Right, and that is how you would do this question here. Okay, so now let's do part B. Alright, let's zoom in. The points of L, M, and P line the circumference of a circle whose center is O. Line NP is a tangent to circle at P, and OMN is a straight line. The line PL is a diameter and angle ONP is 24. Calculate each of the values of the following angles. Show detailed working when necessary and give reasons to support your answer. Now, when I look at things like this, the first thing I like to do is type out all my rules, right, that I could determine from this. So the first things first, the angle in a triangle opposite. So the angle I'm talking about is LMP. So angle LMP is in a triangle LMP, right, is opposite the diameter, hence angle LMP is 90 degrees. Right, that is the first rule that I have seen just so far. Next one is, so let's just write that out. So from that information, we know that this angle here is a 90 degrees triangle. Next thing we know is an angle at the center of the circle, an angle at the circumference of the circle produced by the same chord is double. Right, so the angle at the center is double the angle at the circumference. Right, so I just typed it out, angle POM. So this angle here is twice the size of the angle PLM at the circumference of the circle produced by the, so angle POM is twice the size of the angle PLM at the circumference of the circle produced by the same chord. Right, again this angle is at the center, right, angle POL at the center is twice the size of the angle, right. The next one here, so if we call this, let's just call this, if we call this X, this should be 2X, right? Next one is any tangent that intersects or meets the diameter of a circle or radius of a circle, they will intersect at 90 degrees. So this here is 90 degrees. Alright, so tangent PN, not PN, PN. PN intersects the radius OP, or we could look at the diameter LP at 90 degrees, hence OPN is 90 degrees. So therefore this triangle is also a 90 degrees triangle. We also know that triangles, the sum of triangle, the sum of interior angles, sum of interior the sum of interior angles in a triangle is 180 degrees. So therefore, this would be 180 and also this would be 180. Right. So the sum of interior angles in a triangle is 180. So PON, that is this angle here, which we call 2x, or PN, which we said is 90 degrees, right? And then ONP, which is 24, is equals to 180. I put it here. Then we're looking at this triangle here. We know that LNP is 90. Then PLM, which we call it X. Then we have this angle down here, LPM, that's this angle here, which we just leave it as that, is equals to 180. Alright, so these are all the rules that I've seen thus far in this diagram. So any of the angles that they ask us to calculate, we should be able to. So first off, they said calculate the value of each of the following angles, showing detailed working when necessary, and give reason to support your answer. Angle PON. So PON, right? So immediately for PON, we would have to say PON is the sum of interior angles is 180. What else do we know about that? We also know that the tangent PN intersects the radius. So therefore this angle here is 90. This is what was needed to find PON, right? So I will just copy and paste it. Right now, obviously, you don't have to do this, right? You cannot copy and paste. But I like to use all the rules or place all the rules so I can see it clearly rather than just start. Right, so I will now put PON, right, which we dub as 2x. Right, so we know that PON is equal to 180 subtract 90 plus 24, right? 180 minus 90 plus 24 is 66 degrees, right? So this is 66 here. So immediately in my mind, knowing that the rules, I know that this is 2x, so this would actually be 66 divided by 2, which is equals to 33. So if they do ask you for this angle here, you know it's 33. Right, so let's see, PLM, which is exactly the same thing that I just now said, right? So I would use the angle POM, no, right, the angle LMP, no, POM, this one here, angle POM at the center of the circle is twice the size of angle PLM at the circumference, hence produced by the same force. So I'm going to copy this, put it in the next page. Let's just zoom in. Right. So you could put N instead of M because N and M lie in the same line, right? Not lie on the same line, make the same. Yeah, M and N does lie in the same line. So it's up to you, whichever one you want to put. So angle PON is at the center of the circle. We know that PON, which is what they just now told us to find out, PON is 66, therefore PLM would be 66 divided by 2, which is equals to 33 degrees. Right, and that is how you would calculate this one. Next one, PMN, PM So they want to calculate this angle right here. Alright, so first off, you need to calculate this angle here. Alright, so again, the sum of interior angles in a triangle is 180. Alright, so can we calculate this angle here? We can. Let's do this in a different color so we can see it. So we can calculate this angle here. Right, and then to calculate this angle here, it would be 90 minus this red angle here. And then this one would be 24 plus the green angle subtracted from 180 would give you this angle. So let's first find out this angle here, this red angle here. So the red angle, we know this is 33, this is 90, and this angle here would be 180 minus 33 plus 90. 33 plus 90 is 123. 180 minus 123. So this is 57 degrees, right? Green angle here is going to be 90 because remember the green and the red does make up 90 degrees. So that's 90 minus 57. 90 minus 57 is 33. Right, so this angle here would be, let's do this in black, 180 minus 24 plus 33. 24 plus 33 is equals to 57. 180 minus 57 is 123. Right, so therefore that angle there would be 123 degrees. So PMN, that's this angle, you would have to say that right, look the image there so I can put my rules. We can say that PMN is equal to 180 subtract MNP plus MPN. So it's 180 minus PN, MNP is 24 plus MPN, which we don't know, right? And MPN would be equal to this angle here, angle OPN minus OPN, that's 90 degrees, minus OP minus OPN. Right? So OPN, and then we know OPN is equal to 180 degrees minus PLM plus LMP. Because 180 subtract PLM, which is 33 plus LMP, LMP is 90, which we got to be 57. Right? Then we said OPN was 90, subtract 57, which was 33. So this is 33 here. That is how we got 123 degrees. right? And yeah, that is what you would have to write down, because they did say calculate, show detail working, so they want to know your detail working for these things. Yeah, and show reason for your answer. So this is how you would do it. You can put all interior angles. All interior angles of a triangle is 180 degrees. You can also say that OPN is 90 because it OP intersects PN at a tangent, or meets at a tangent of a circle, and that would be your detail working for this. Right, and that is the end of May, June 2025.